Hello, everyone. Thanks for joining. This is Nikolay with my talk for Conf42 conference, Golang track, and the title of my talk is Practical Guide to Testing Go Services. Couple words about me. I'm senior software engineer in Zalanda, working from Helsinki, working on pre-owned project. I started my career with C and did quite a lot of Java. And for the past 6 years, I'm doing lots of Go engineering and also writing lots of tests using Golang. And also I'm author of PGX Outbox library, which is available on GitHub. It's about transactional outbox pattern using PGX driver. So many of you are familiar with testing pyramid concept, which suggests us that a unit test cheap to run, and then we should have more of them, and then integration tests that take more time, more resources to run, so we should have less of them. But there is a new concept called testing trophy, which actually advocates for the idea that integration tests, we should run more integration tests, even more than unit tests, because these days they got extremely easy to run and execute integration tests. And unit tests, they actually tightly couple our code to the test. But in that sense, integration test might have more value because we can have our integration to different external systems like Postgres, Kafka, and so on. And one more idea about testing trophy concept is static tests. It's about basically linters in Golang that many issues, code issues, they can be caught using static analysis tools. Yeah, this is a relatively new concept about testing trophy. So yeah, about testing, I would like to introduce several principles which I'm advocating in this talk. It's about testing layer by layer in our Go services. What I mean layer by layer is basically repository layer, service layer, and HTTP layer. I'm going to use table test everywhere because they're always useful, because they're extensible. And I'm advocating for comprehensive comparison of actual data to expected data. Basically, if we have a struct, we should compare all the fields, and I'm going to show libraries which facilitate easy comparison of all the fields of the struct in the test. And one more principle is to use randomized data for the test, not just some hard-coded dummy values. So there is another library I'm going to show which facilitate how we can use randomized data and improve our quality of the test. Yes, I would like to introduce some demo applications, some example service which are going to test today. The service is about management of the cart of e-commerce. Basically, we are going to add some unique items to the cart because pre-owned items are unique. And then we can remove items from the cart and we can get the cart basically by the user ID or owner ID, which I refer in this talk. I'm going to use Postgres as the main database and PGX driver, which is the most popular. I'm going to use Gene framework for HTTP, and I'm going to use hexagonal-like architecture, which in this case of this very simple application, it's very similar to a layered architecture with just a repository, service layer, and an HTTP layer. So this is a hexagonal architecture. In the small center, we have the main, which is independent on the application. And application is basically our business logic, our service. And then we have infrastructure, and infrastructure is some ports, which are interfaces, and adapters, which are implementation of interfaces which connect our application business logic with database and HTTP. Yeah, let's start with repository layer. How can we test repository layer, the layer which would talk to database? One of the main idea here that we should test against a real database, not a mock database, because with these days, we can run new database exactly the same way as production in container, Docker container. And then we can test our queries and our code against that. This is exactly the same database as production. And the idea is that actually spin up the containers from Go code. This way we can manage life cycle of the containers in the test together with the test itself. So it's not completely independent. Yeah. So for this there are two libraries how we can start a container from the Go code. One of the most popular is test containers Go, which I also use the most. It comes with several, actually more than 30 modules, so which simplify configuration for the person who writes the test. So I use it quite a lot for Postgres and local stack. And local stack is an emulation of Amazon Web Services. It has quite a lot of services, SNS, SQS, S3. I found it very useful for my projects. But yeah, we are going to see how one can use that for Postgres. Actually, it requires just a couple of lines of code to run Postgres container from the Go code itself. So in here you can see there is a basic wait strategy is used, and the idea is that before you start your test, you need the container to be ready for the test. And because we're using this model, it already knows how to wait for the Postgres container to be ready for our test. Yes, as just an example, I show that one can provide initialize scripts which initialize our database, creates the tables, maybe insert some data for the test, and so on. And then from the container, one can get a connection string. I show example in the code. There's idea here that it uses a randomized port on the local machine. You can start different containers and they don't collide with each other, and your test can run in parallel. One of idea is that we should to manage the life cycle of our containers, like in which part of our Go code we should actually start the container. And I'm advocating for using a suite package of Testify library, a testing framework. And it's because it has lifecycle hooks which you can run before all the tests in the suite and then shut down the container. I found it much more convenient than using test main, for example, or using sync once, or starting the container per each test, because then it might be actually costly and cause some delays. This is the example how we can introduce testing suite from the Testify library to our code. We just need to embed the suite struct into our struct, and in the cart repo suite, I add test container, so I can in the lifecycle hook I can start the container for the whole suite and then shut down the container after all tests are run. And the last line, they show how to run the whole suites, which is going to run all the tests in the same suite. It shows how we can set up the suite. So there are special methods called setup suite and teardown suites. And in here, I'm doing some initialization. I'm starting Postgres container. I'm initializing PGX connection pool, and then I'm initializing repository layer using the connection pool. And in teardown suite, I'm just stopping the container, terminating the container. Actually, it's not needed because by default, test container library starts a special container, second container, which is called Rike, which is responsible for killing all the containers if they're not terminated after the test. But yeah, so we're just helping Rike container here. And then this snippet shows how can we attach our actual test to the test suite. I'm going to test a method which add items to the cart. Before running the table tests, some configuration can be done. And then I need to use this suite run instead of trun. So yeah, basically I run the method from add item method from repo. I provide some parameters from the test. Then later I can get the actual card and compare the card to assert the card with the expected one. And for assertion, it's very handy to use GoCMP library, which I'm going to explain right now. So GoCMP library, it's actually about semantic equality, and it's much more powerful than reflect package and deep equal method, which come out of the box in Go. And then basically the idea that one can try to use that default behavior of GoCMP library, but if it's not working, then one can customize the behavior using options. So eventually you would get basically all the fields of the structure. They can be compared to each other. The test itself, the comparison itself, are much more comprehensive. And by the way, this is not official Google product. So yeah, here I show how one can use GoCMP. At the most bottom of the snippet, the diff method is the most basically default behavior. You can just compare like expected card and actual card. And if it doesn't work, then you can start customizing the behavior. You can customize, you can exclude certain fields from the comparison. And here I am excluding created at field. For example, you can also customize, you can guide GoCMP to actually treat empties and new slices equally to each other, because by default they're not considered the same, but you can customize that behavior. And also like certain structures which have unexported fields by default, they wouldn't be equal, so you can customize that behavior. And I'm customizing the comparison, how the currency are actually compared, without customizing behavior how currencies are compared. That I would basically get the error, but without. Yes. So we are done with repository layer, and let's think how we can test the service layer. There are a couple of concepts here, and one of the main idea is that we have to use pure tests if it's possible. Sometimes it's not possible because service can have some external dependencies. It can depend on a repository layer. It can depend on other ports in the terminology of hexagonal architecture. So basically we should mock those dependencies, and that would simplify our testing of the business logic. It was significantly simplified. So in Go world, there are a couple of tools which simplify using of the mocks. First, the idea that we have to depend on the interface, not on the specific structure. And then if our service depends on interface of repository, then we can use mock generators and then use generated mocks of repository and other dependencies in our tests. Historically, I have quite experience about using Golang mock, which is now deprecated, but Uber mock is basically the same thing, but they're not compatible. And the most popular tool right now is Mockery to generate mocks for Golang tests. It generates mocks from interfaces, and it follows conventions which are defined in Testify mock package. So it provides much simpler API comparing to Uber mock or Golang mock, and it's also the most popular option right now. I'm going to show you example how one can generate mocks. So our card repo is interface with couple of methods which we implement somewhere else, and which we already tested basically using test containers Go. So by using Go generate tag, we can specify and configure what mock we want to create, how the name, the mock structure, what would be the package, output package, what would be the output file name, and so on. And then one needs to install the mocker generator to the local machine, and then actually run go generate command, and then the mock file would be generated, and then this mock can be used in the test to mock dependency, to mock behavior of our dependency. Here I show how one can use setup, configure mocks to use in table tests. Basically, this new mock setup function has to be introduced for each table test, and then basically it's a quite simple API that you can provide. Okay, what method is going? What method you expect to be called, and what value you want to return, basically. And there are certain things like you can specify mock anything. This is for the Golang context. And then, yeah. And then when you actually run the test, so you create the mock, and then you use mock setup function to configure the mock. Then you pass the mock as dependency. Then you create a service, card service. In my case, then you would call certain methods in the service, basically calling some methods, making some assertions. And at the most end, it's not obligatory, but it's handy to call this assert expectation function. Yeah. So this is quite straightforward. Just remember that about the mocks, that one should pass dependencies as interfaces, and then mocks can be generated. But this is one more topic about how we provide the data for the test. Of course, we can use hard-coded data, but there are several options, and I found myself personally this Go Fake It library is the most useful for my case. I show in this snippet how we can create a fake card with some faked values. So instead of hard coding, we can use Go Fake It library, which has dozens of different methods. It can provide you some randomly generated UID, some price value, some currency, and it has like dozens and dozens of methods, and it's really useful. So first of all, you don't have to hard code the data yourself. And first, each time the data you use in the test, it's different. So sometimes you can find some bugs which would be otherwise really difficult to find because of this randomized data. All right, now we completed how the topic of how we test the service layer, and now let's proceed to HTTP layer. How we can retest HTTP layer? The first principle is we have to mock the service layer, which is used by HTTP layer. So we can use the same mock generator, mockery, and our server. It means that our service has also to be interface, and to be dependency has to be provided as interface. And then actually, for the HTTP layer, there are two things we can test. The first thing, we can test each HTTP handler in isolation, and then we can test the whole router of the whole application. Sometimes people combine them as use just one type of test, but ideally they have to be separated. I explain in following slides why. And it's quite handy to use HTTP test, which it's a standard library. It comes with Go out of the box, and it's very handy to test that. But it can be a little bit verbose to use that library, especially if you want to assert different, more advanced things, like you want to assert the body. Then maybe be flexible how you do the assertion. So there are a couple of libraries below which provide like more fluent API, how you make the call and how you assert what you get back from the call to HTTP handler or the router. All right, here I show, okay, this is our Gene handler. I use Gene framework for HTTP. It's one of the most popular, and we have this get card method which takes Gene context and returns us the card and some JSON HTTP status. Okay, so how can we test this Gene handler? So first of all, we need to create the handler, and we configure the service as the mock. We inject that service as the mock. We configure the mock. And here comes like the more interesting part. We need to create a recorder from HTTP test package, and then we would use that recorder to make a call to our handler, and then back from the recorder we would be able to get the data, because it would record like what was our input parameters and what was like the output. Basically, if we want to test the gene handler without testing the whole router, then there is a specific method to create a gene context. So we can provide the gene context basically to our method, and we use recorder to create the gene context, and we provide some parameters. We actually make get request. We prepare get request, and we set that request into our gene context, and then finally we make a call to our handler with constructed asserted gene context. And then, after we make a call from the recorder, we can get what was the HTTP status code. We can compare that. We can set that to the expected one. And also, it's possible to get the body. We can get the body back as a byte array. And then we can convert that. To our card. And then we can compare card, assert the last line of this code snippet, and of course we are going to use P library under the hood to compare the card very flexibly and with minimum amount of code. All right, now I would like to talk a bit about why should we actually separate a router and handler test, because the idea is to focus on different things. When we test a handler, we are going to test how the handler interacts with our service, the dependency we injected, how it handles the errors, how it processes the input, what are the edge cases, edge case status codes, and so on. So it has to be deep and comprehensive test how our handler behaves. But for the router, it's a bit different. We have to focus on the router mechanics. So about that we actually set up correctly the handlers to each route, and if the route path is correct, and how parameters are being extracted, and if middleware is applied correctly or not. And then on the router, it's enough just to test a happy path, because we are focusing on the different things on the routing mechanics. And I'm going to show you how we can do a simple test for the router. So in here, we actually need to test the URL, the path, which is going to be code, and what we are going to expect. And again, we need to configure the mock for the service and what's the status we're expecting back. And then here again, we have to use HTTP test recorder. And then we set the router is our gene engine, basically, which we construct somewhere outside of here. And then we create a request, HTTP request. Yes, and then we can provide HTTP request to the router and see what. So again, recorder would record what was the input, what was the output, and we can assert them. And here I'm setting the status code here because it's about the happy path. Comparing the body here, it can be done, but it's not necessary, because our handler test should focus more on asserting the body. But here we are just doing the happy path. All right, in the context of tests, it makes sense to talk a bit about the coverage and coverage report. The first snippet shows that we can generate a coverage report locally. We can convert that to HTML, and we can open that in a browser. It can be combined in a single command, and sometimes it can be handy and curious to see what parts of your code are not tested enough. But there are even more automatic solutions. There are services where you can upload your coverage reports if you maintain open source project on the GitHub. then it's also quite handy. Like for example, I use coveralls, and where you can upload your coverage and report, and it also provides some UI, and also it can track for you if your coverage increased or decreased. All right, so we are close to the end of the talk. Some more tools I would like to mention, which are interesting to explore, maybe use in your projects. So Packed Go is the tool which facilitate contract testing. So this talk was focusing on testing a single service, but in multi-service environment, it makes sense to test just more than one service, and then this Packed Go tool can be useful. Also, recently I started to use this Testify linter. This is a linter actually tells you and alerts you if you are not using the Testify assert and require library correctly, which is sometimes can be quite useful. And of course, it's not so critical, but yeah. All right. And also it makes sense to think about testing the service when it's deployed to the test cluster. In here, I indicate that the smoke plus testing. So like the smoke test is like the most basic one, but once you deploy the service to a test cluster, you can think of some integration test with other services, or maybe end-to-end test which involves multiple services, but this is outside of this talk. All right, takes away. Here I summarize the libraries which are useful to use, which when you do testing the Go services. So for the different levels, depending on what layer you're testing, like I would mention specifically Go CMP and Go Fake It, test containers, Go Mockery, and of course HTTP test for HTTP interactions. And thank you very much for attention, and happy testing.